So I'm sitting here trying to think through how to knit all these pieces together. So right now we've got the let's see. Right now we've got the state machine going for the ultrasonic sensor that's measuring the distance, or like measuring the echo, turning that into a distance in centimeters, and then we have a threshold for when we want to activate the lid, which is about 30 centimeters away, and then we're mapping it so that as you get closer, the distance away is mapped to the starting and ending angle for opening and closing our lid, which is like 30 to 120 degrees. So this works. This kind of works. Like if we do it, and if we move really slow, we see that as we get closer, the lid opens and closes. But this is so there's a couple of issues that we're dealing with. One is this kind of like herky jerky nature of it. Um, Another is if we get really close and then we move it. Right now, even though the distance is past the threshold, so it's past 30 centimeters, we're still like the last thing that we wrote is actually the angle that has it open like this. So it's going to remain open even if the thing isn't actually in front of it. So it's not until you get the next close readings that it starts like kind of opening and closing. And then the other thing is one of the issues that we were running into earlier, which is kind of like the outlier measurements, because this is working with echolocation, and because it's dealing with a whole bunch of different factors like the speed of sound through air, and the fact that it's not hitting a specific point. It's hitting like an object or objects in front of it and being reflected back, and all this kind of stuff. Sometimes you get like odd readings, kind of like that. Um, so I was trying to think through how to resolve it, and I think the first thing, let's see, the first thing I want to do is actually kind of refactor the way the lid's opening and closing, to be a little bit more of a smooth transition. And my idea, I've not tried this yet, so we're just gonna put it in place and see if it works, is that we always want it to be moving kind of like in a smooth motion. And really, like, the only thing that should change whether or not it's moving in that motion is, I mean, like, it should be the distance away, but we shouldn't just go from wherever it is right now immediately to that as fast as we can. It would be good to have an interval for the stepper motor, or the stepper motor, God, the servo to like, so that it kind of like moves in one direction or the other in like kind of a steady step. And then what we do is we kind of change the target that it's aiming for. Um, so for instance, if the lid's angle is at like 90 degrees or so, um, ah, if the lid's angle is at like 90 degree, or well, 45 degrees or so, and the because the person is standing at whatever the distance is to get to 45 degrees, and they back away from the treasure chest, we know that we're going to want to close the lid. So we set a new target, which is like towards the starting angle, like 30 or so. And then we like, at each interval step we start closing at like a regular speed, closing the lid. And then if they all of a sudden they ran up to it, like right up next to it, and we wanted to go to 120, we just change the target and then like start stepping open at that interval. And I think that will kind of like ease the lid opening and closing, making it a little bit smoother and stuff. And it will decouple the lid a little bit more from the readings from the ultrasonic sensor. So because we're not mapping directly to it, we're just like, using it to like slightly decouple to ease it open and close. So that's the first thing that we're going to do, and then we'll tackle the other issues. So how are we going to do that? So we know that we're going to want an interval for the servo, and actually we already have an interval. I ripped out all the other codes. I just like updated I created a Git repository. I don't know why I didn't have that before, but we already have an interval for the servo. Let's put it at 50. Starting angle. Do we want a starting angle and lid open and close? I don't think so. If we need to, we'll add that back in. Instead of layering into all this procedural code, I'm gonna pop out and like write a function for all of this. So let's see. Where's targets? So we'll do the servo step towards target, because that feels like a good name for what we're trying to do. And then what do we need to do? So there's the angle, the current angle that the servo is going to be at. So we'll start the current angle at the starting angle. So because we don't want to go all the way down to 0. And then let's see. So current angle, we'll start there. And then let's see, we'll need a target angle. And that will be, let's just declare it, but not actually assign it yet. So the target angle will be what we're changing to start stepping the current angle towards it. Okay, that makes sense. Okay, so servo step towards the angle. So what is going to happen? So if we call this, first thing that we want to do is check to see if let's see, direction. How do we do direction? So for any given angle, we know that we have the this upper and lower range, and the target's going to be somewhere in between that range. So if the current angle, if the target angle is greater than the current angle, then we're going to be stepping in a positive direction. If the target angle is less than the current angle, then we'll be stepping in a negative direction. Okay, so it will be, well, first let's exit early if there's an issue. If target angle, if it's undefined, I'm thinking JavaScript. Let's see, if there's no target angle, then let's exit early. We can compact these later. If target angle minus current angle equals 0, so if we've reached our target, we'll return early. Oh, God, I've been writing a lot of JavaScript in Node. I thought that was a thing. Oh, it is a thing. It is a thing. Okay. Okay. Yeah. Okay, I understand C++. Hold on. There we go. Okay. We'll exit early, and then if either of those conditions are true, then we're just gonna exit early. And then if neither of those are true, then we know that we need to figure out which direction we're going to move in. So we can do do we need, oh no, we don't need direction. We just need to know if we need to increment or decrement. So because we're going to be stepping this current angle towards target angle, and it's all going to be in a positive range. So we don't need direction as much as we need to know if we need to increment or decrement. So if target angle minus current angle is greater than 0, and I can already see where we can compact some of this. So if we subtract the target angle from the current angle, it's greater than 0, then we know that we're stepping towards the target angle, so we need to increment. So current angle plus plus, and then current minus minus, and then stepping towards target. So yeah. So we're at 30, and our target angle is 90. Then 90 minus 30 is going to be a positive 60. So we know that we're going to increment. We're going to keep going there. If we're at 30 and the target angle is 20, then we're going to do 30, or we're going to do 20 minus 30, which is negative 10. So we're going to be stepping down. We're going to be decrementing. And because we're just decrementing the current angle, we're still sending in positive values. I think that, yeah, we'll test it out and see if it works. Lid.right, current angle. Okay, and then we'd be doing that until we got to current angle. Yeah, and I can already see, we're doing this right here. We could probably compact these so that we're doing we do this math, and then we do a switch on the result, and then we compare. Yeah, whatever. We'll see in just a bit. Oh, step towards target. So when does that happen? So if we're in threshold, so we'll keep the angle, and then instead of the lid right, we'll say target angle equals angle. And then let's see. Do you want to step towards in there? No, we want to step towards step target from here. Okay, so we're in we're using the global. I'm okay. Usually I'm not a fan of using global state outside of things like state machines and stuff like that, but it's kind of still in the state machine. So okay, so we're getting the angle, we're saying that as the target, the current is set to something already, and then we'll be updating we'll step towards it. We'll step towards it regardless if the distance is there or not, so that we can continue even if someone steps away, which solves one of our other problems in theory. So let's see what happens. I should have put some serial output, but let's see. Well, that's uploading. Oh, we're also... Okay. Okay, there's one of the things I forgot is the interval for here. So, let's hop out here. And then say if now minus servo. What do I name it? Is greater than or equal to the servo interval. Then, not happy about. Okay. Then we will step towards the target. Okay, so because we want to make sure that we're handling this at separate intervals so that we can decouple these two things anyway. And actually, we see this stepping, but it's still tied in with the ultrasonic interval of a second rather than the servo interval of 50 milliseconds. So okay. Let's see. We'll say that we're setting a new target angle, and then you know what? This is dumb. We don't need this one, so we'll just like define it. We'll start the target angle as the same thing. Why is my symbol navigation so slow? That was wild. Okay. So we don't need that one early return. I was going to go through and optimize later. We don't need that undefined early return, because really that's only going to happen, that would have happened at the very beginning, and then as soon as we didn't assign, it would be unneeded. Plus we could just hit that same thing with this early return, which could probably be cleaned up as well. And then we can say so if we hit this conditional, we'll do that. We're gonna definitely rip that out because I'll spam the console. So that's the target. And then to negative move towards target. Yeah, we're going to rip out all these because it's just going to spam the console, but it'll give us a good indication. So now we should see the speed of the servo, or of the lid opening and closing at a different rate than the ultrasonic sensor reading, and then we'll start getting messages on how our step towards target function is firing. Okay, so okay, yeah. Oh, we need to limit. Okay, hold on. Can we get back? Come on. Close it up. Oh, woof. Okay, so it seems like we're still gonna want to average stuff out because we're still getting these little fluctuations. We could also like could increase the interval for the ultrasonic check, which is probably safe to do now, and then creep and open. Let's see. We know our positive's working. Come on, step down. Okay, let's... Positive move, let's see, and then... Let's see, if the target angle, so where do we want to handle... Oh, yeah. Okay, we're gonna kill the power for now. Okay, so one of the issues that we're running into now, and you can kind of see it here, the servo is overextending the joint, and we definitely don't want that. So we need to put a programmatic limit so that we literally can't step past the upper, let's see, past the ending angle. So are we sending, let's see, getting a lot of distance to object 0. That must have been when my hand was right over it. Oh, we were never sending the angle. Okay, so Okay, so now we'll get an idea of what the new angle is. Now I'm wondering, should we limit the target angle? Let's see. We should handle the limits in here. Okay. So basically, we want to make sure that we don't overextend or underextend our angle. Right now, we're doing this conversion based on distance, and we're limiting. Well, we're limiting here. We're limiting the angle at the map, so it shouldn't. It shouldn't be sending. Yeah. Okay. Let's see what this target angle is, because I was gonna say we could do like a max and a min. So in our step towards target servo target function, so we make sure at that level that we can't go past our limits, and it still may be worth putting it in there just to like have a safety check, just in case we call that function from elsewhere and we don't have this map going. So yeah, we probably do want to put that limit in, but really we shouldn't be running into that yet. We shouldn't be running into that because here, the one place that we're actually calculating the angle, we are already limiting ourselves to the starting and ending angle. So I'm not sure why we'd be overextending. There's something weird. And actually, it reminds me of an issue that I was having the other day. So let's do this. So we already... at the very beginning, we set the starting angle, and then we open it all the way. Let's do a... Okay, so let's... it'll start close, and it'll open, and then close. Actually, let's do it for 2 seconds. Oh, yeah. Let's also plug everything back in. Why are you overextending? So I did a little experimentation. Like really, I just went back in my code and grabbed the stepping up and down, and kind of like tested that with different. Basically, trying to figure out like if there's something that I could do that kind of resets the encoder in the servo that would make it think that it should overextend, and everything seems fine. So I think that we're going to leave that print angle. We're going to take out the early exit for now. I just want to see the angles being sent. So let's try that. Okay, so okay. That's fine. Wait a minute. Why did it extend when it was trying to go down? Interesting. Okay. I think I know what's... Oh, okay. I think I know what's going on. You can stop freaking out, box. Okay, so we are going through and... we are scoping everything to the angle of 120, or well, our beginning and ending angles, our starting and ending angles of 30, 120, so we can make sure it's safe. The servo motor will not extend past those, or at least if we keep those within the range, it will not extend past those. But where we're losing it is we set the angle, or as the target angle, and then whenever our servo step towards target function fires, it is taking angle and it's incrementing or decrementing, but is not limiting to it's not checking itself for the inner and outer bounds, and it's using, whenever it's writing, it's just using this current angle, which is decoupled, which is kind of what we want. Let's see. So let's do this. So, let's see. Current angle. Current angle is current angle. And then, let's see. Well, let's pull it out now. Okay, so, minus. Okay, and then target angle, yeah, these are, okay, they're both ints, they're both unsigned. Okay, so current angle, and then let's do the difference, and then we should do the target angle. Okay, so we got the current angle, target angle, and then the difference. Let's do it here so we can check our math. Let's put in spaces so we don't drive ourselves crazy with the format. Okay, so we'll be able to see the target angle that we're aiming for, the current angle, like the current state, and then the difference. And then, let's see, if we can replace this with difference, the difference is positive, difference is negative, we decrement, and then we write that. And then what we want to do, if it's just as a safety, because I don't like when that overextends, we'll do a max. What is max in C++? Max two numbers. Okay, there's just a max function. Okay, so current angle, and then let's do max of so the max of the current angle and the ending angle. So if it, so we, okay, so I'm putting a max and a min in, because if it turns out that the difference is, or like if we increment or decrement and it turns out that that is past our upper point and our lower point, we could end up with an overextend. So this will make sure that it'll make sure that for some reason the current angle passes one of those boundaries. We just reset it to the boundary, and that should be fine. So let's upload it and let's see what is up. Okay, let's plug it in. Okay. Alright, let's close the serial monitor and then take a look at what we're seeing. So target angle is 90, current angle is 30, so difference is 60. Why are we jumping? Oh, is it because of our limiting? Oh, no. Oh, okay, I had this backwards. Yeah, because if we do that, we want to grab like if it's overextended. So if the current angle is 140, and we would be overextending, we want to compare 140 to our ending angle, which is 120, and then take the minimum of that, which would give us our ending angle, and same for the max angle. So yeah, I had that backwards in my head. Right, so let's see where we're at here. Hey, it's better than what we were running into before. Oh, yeah, that's way better. I hope I didn't just bump let me check the camera. Yeah, actually, I'm like doing this right into the camera and not even noticing it. So, okay. So as we get closer, it's opening up more. And then as we back away, it's closing. And it's way smoother. Yeah, decoupling these is definitely good. I feel like we might want to change some of the range as far as what we are, like maybe the distance range. Oh god, but that is so cool to see. Yeah, and I'm wondering, like, maybe we should update the ultrasonic. Okay. Let's. This is good. This is good progress. So let's do some interval adjusting. So let's switch this every second because this will be a little bit smoother now that we've decoupled the servo interval from the ultrasonic interval. Lid activation threshold, we'll leave that for where it is right now. Actually, I'm gonna drop this to 500 because with those two decoupled, then we could do a higher speed of reading. We could do the updates because we know that the servo is always going to move at a steady rate. And we're not going to get that like clattering back and forth that was disturbing. Oh god, I love it when it starts getting closer to like that final smooth finished product. Where are you going? Where are you going? Yeah. Yeah, I think that another thing that we should do, because like this is really cool to like kind of see it open and close as we get closer and farther away, but someone's not going to walk directly up to and stand like a centimeter away from the box. So we probably want you to be able to have it like the box fully extended at like, probably, what is this, like 20 centimeters or so? I don't know. I can't think of metric very well. But we should have the box fully extended about right here. And then read a little bit further out. But this is progress. Very cool.